let's just look at this easy example that you guys have seen before. Okay, so this is a non-inverting amplifier, right? We have a negative feedback, we have an op amp. Let's just like say it has two power supplies, right? And I want to find the transfer function of this system. So just like means that I want to know what is the transfer function of this system, right? This is just a review of ELEX 3130. If you want to do that, it's very simple. I'm just gonna like simplify things, like because we have negative feedback, op amp can actually make these two voltages the same, so this voltage is going to be the same as Vin. So if I look at this current, it's going to be Vin over R1. This is actually in time domain. I'm doing everything in time domain. And this current, it's going to be V out minus Vin divided by R2, right? And you guys remember that op amp has a very huge internal input impedance. So this current is almost zero. So we can assume that these two are exactly the same. The same current that moves towards this direction goes here, right? And if you simplify this, I'm just gonna factor out Vin times 1 over R1 plus R2, 1 over R2, it's gonna be equal to V out divided by R2. These are, keep in mind that this is, we're doing everything in the time domain. Okay, so now V out, it's gonna be equal to V in, did I do everything right? V in over R1, V out minus V out, V in times 1. Yeah, so V in times R1 plus R2 divided by R1, because R2 and R2 cancel out, right? So this is in the time domain, right? But there's no, like, this is just like a constant because our resistors are constant. So even in the frequency domain, it would be the same. If I take Laplace transform of this one, like the only difference is that these become V out of S and V in of S. So the transfer function of this system, if I just like look at this as a box, the transfer function of this system is just going to be, as you saw before, R1 plus R2 divided by R1. Okay, so doesn't matter like what input voltage you have, you want to find output voltage, right? You take the Laplace transform of this one multiplied by this, you find the output voltage in the S domain. You take the inverse Laplace transform, you find the output voltage in time domain. What kind of filter was this? So this transfer function that we saw was R1 plus R2 over R1. Or R1 over R2, sorry, I can't remember. Yeah. What kind of does it like pass low frequencies or high frequencies, or it's actually, this is a transfer function that's supposed to be constant for all frequencies, right? So like it's all pass filter. It passes all all frequencies. Of course, this is an ideal op amp. You've seen in ELEX 3130 that like any op amp has a bandwidth that after that everything we talked about ideal op amp doesn't apply to it. But if we assume that we have an ideal op amp, it can be assumed as an all pass filter. Okay. Now excuse me. The next concept we want to talk about is the concept of feedback. Okay, so in many systems are open loop, means that you give an input, you get an output. So for example, in the buck converter, boost converter, or any of the DC-DC converters that we've seen, we give a certain duty cycle, we get a certain output voltage. Okay, so this is an open loop. There's no feedback. We don't measure output voltage to make sure that our output voltage is the desired output voltage, right? We just like trust everything to be exactly like our theoretical calculation. In practice though, there's so many noises, right? And everything, like all the resistors, capacitors, these are not ideal elements. So like a capacitor actually might have some small resistance to it, and like all the resistors that we see, like they have some tolerance, right? Like plus minus 10% or something, right? So in many cases you expect to get a certain output, but because of all things that happening and like all practical non-ideal parameters here, you actually get something which is lower or higher than your desired output, right? So that the concept that we can take advantage of to make sure that we get what we want is basically, let's say if this is our plant, this is like our system or plant, our main plant that we want to control. So this is, let's say like we apply a certain input and we want to get a certain output, right? So this is like what we want to get, right? So what we do in many cases, we apply as our input, we apply what's the desired output, right? And so we monitor this one, we measure this one, and we subtract these two. So this is gonna give us an error, right?